Okay, so step number one is to write what is the value of n. Okay, so from here you can see your value of n is equal to 1, where the value of n can be obtained from here. Okay, so n is equal to 1. In step number 2, you need to find what is your fs, where fs is the Laplace transformation of the function ft. Okay, so now our function ft is sine 60, therefore we will find what is the Laplace transformation of sine 60. Okay, so to find what is the Laplace transformation of sine 60, we need to use the formula of a over s square plus a square. Now your a is equal to 6. Therefore, what you will have for the Laplace transformation of the function ft is equal to 6 over s square plus 36. Okay, so next step is step number 3, where you need to differentiate your fs n times. Okay, so for this question you need to differentiate your fs once, okay, because your n is equal to 1. Therefore we have fs equal to 6 s square plus 36. Okay, if to find f prime s, you have two options. Either you want to use the quotient rule, or you can bring the s square plus 36 up. Therefore what you will have for your fs is 6 s square plus 36 to the power of negative 1. Then we differentiate fs, we will get f prime s. Therefore what you will get here is negative 6 s square plus 36 negative 2. Don't forget to differentiate the inner function here, you will get 2s. Okay, so your f prime s is negative 12s s square plus 36 to the power of negative 2, or you can bring it in the denominator back. So what you will have is negative 12s over s square plus 36 to the power of 2. Okay, so next we go to step number 4, where in step number 4 you need to times negative 1 to the power of n with whatever result that you have in step number 3, which is your f prime s. Okay, therefore you have your n is equal to 1. You need to times your negative 1 to the power of 1 with your f prime s here, negative 12s over s square plus 36 to the power of 2. Okay guys, so negative 1 to the power of 1 is negative 1. Negative times 2 negative is positive. Therefore your final result will be 12s over s square plus 36 to the power of 2. Find the Laplace transformation for a function t square cos t. Okay, where this is the combination of the function t with a function cos. Therefore we want to use the derivative of t transform method. Okay, so the first step for derivative of t transform method is to find what is the value of n. So now your n is equal to 2. The second step is to find the fs, where fs is the Laplace transformation of your ft. So for this question, your ft is equal to cos t. Okay, so we can find the Laplace transformation of cos t by using the formula s over s square plus a square, and for this case our a is equal to 1. Okay, so what we will get for our fs, so fs now is equal to s over s square plus 1 square equal to 1. Okay, so next you need to move to step number 3, where you need to differentiate. Okay, you need to differentiate your fs n times. Okay, so for this equation you have your n is equal to 2. Therefore you need to differentiate 2 times to find what is your f double prime s. Okay, so let's have fs equal to s square plus 1, s over s square plus 1 here. Okay, this one you need to differentiate by using a quotient rule, since it involves a fraction. Therefore the numerator is u, the denominator is v. Let's list our u equal to s, our v equal to s square plus 1. Therefore we have our du equal to 1, our dv is equal to 2s. Okay, and don't forget that this is the formula of our quotient rule, which is v times du minus with u times dv divided by v square. Okay, divided by v square. Alright, now guys, so let's write our f prime s here. So v times du, so we have v times du, we have s square plus 1 times with 1 minus with u times dv, so s times 2s is 2s square over v square, so s square plus 1 square. Okay, so if we simplify the numerator, we will see that we have s square plus 1 minus 2s square over s square plus 1 to the power of 2. So here s square minus 2s square is negative s square, therefore you will have 1 minus s square over s square plus 1 to the power of 2. It's not yet complete because you need to do a second derivative. Okay, to find the second derivative, we still need to use the quotient rule again. Okay, so this one is u, this one is v. Let's list down what is our u is 1 minus s square, and our v is s square plus 1 to the power of 2. Therefore, we have our du equal to negative 2s and our dv equal to 2 s square plus 1 to the power of 1 times with 2s. Okay, so now let's use the formula of quotient rule to find what is the second derivative of fs. Okay, so v times du, we have v times with du here, so we have negative 2s times with s square plus 1 to the power of 2. Okay, minus with u times with dv. Okay, let I write it again because we don't have enough space here. So v times with du, you will have negative 2s times with s square plus 1 to the power of 2 minus with u times dv, therefore you will have 4s 1 minus s square plus 1 divided by v square, therefore you will have s square plus 1 to the power of 4. Okay guys, so they have a common multiplicator here, therefore you can divide them all by s square plus 1, here on the left 3 and here on the left 1. Okay, so what you will have for your f double prime s, if you simplify this fraction, you will have your f double prime s equal to negative 2s times with s square plus 1 minus with 4s times with 1 minus s square divided by s square plus 1 to the power of 3. Okay, so this is the second derivative of your fs. Okay, so let's simplify which one that we can simplify here. Okay, so let's see how to simplify this one. If we expand the numerator, you will get negative 2s to the power of 3 minus with 2s minus with 4s plus with 4s to the power of 3, and in the denominator let it be s square plus 1 to the power of 3. Therefore, if you see here negative 2s cubed plus with 4s cubed, you will have 2s cubed. Okay, negative 2s minus 6s, you will have negative 6s. Okay, so you will have here s square plus 1 to the power of 3. Okay, then we move to step number 4. When step number 4, you need to times negative 1 to the power of n. So now our n is equal to 2. Therefore, negative 1 to the power of 2 times with the result on this step number 3, which is your f double prime s. Okay, so you need to times negative 1 to the power of 2 with 2s cubed minus 6s over s square plus 1 to the power of 3. Okay, so your negative 1 to the power of 2 is 1. So 1 times the whole thing here is the whole thing here. Let's simplify it to be 2s square minus 6 over s square plus 1 to the power of 3. So this is the final solution. Another example here, let's say we want to find the Laplace transformation for the function t square exponent 5t. Okay, so you have the two combination of a function, the combination of two function, where the first one is a t function and the second one is exponential function. Okay, so for this kind of equation, you can choose either you want to use the first shift theorem or you want to use the derivative of t transform theorem. So let me show you both theorems. Okay, if the first one we need to, if we want to use the derivative of t transform theorem, therefore the first step is we want to know what is the value of n. So now our n is equal to 2. The second step is we need to find what is our fs, where fs is the Laplace transformation of the function exponent 5t here. Okay, so we have our fs by using the formula is equal to 1 over s minus 5. Okay, now in step number 3 we need to find the derivative of fs n times. So here n is equal to 2 means that we need to find derivative of fs 2 times, which is we have second derivative of fs. So let's our fs equal to s minus 5 to the power of 1. I bring the denominator up in the numerator. Therefore, you will have the first derivative fs is equal to negative 1 s minus 5 to the power of negative 2. Okay, and do the derivative twice. We have f double prime s is equal to negative 1 times negative 2 is 2 s minus 5 to the power of negative 3, or I bring it down again, it will have 2 over s minus 5 to the power of 3. So this is the second derivative of your fs. And we move to the last step, with step number 4. You need to times negative 1 to the power of n. Now your n is equal to 2 with your f double prime s you got in step number 3. Therefore you need to times negative 1 to the power of 2 with 2 over s minus 5 to the power of 3. Okay, therefore you will have positive 1 here, so your final solution will be 2 over s minus 5 to the power of 3. Okay, this is the answer that you get by using the first shift theorem. Okay, by using the derivative of t transform. So I read the method here. Derivative of t transform. Okay, next we want to solve this question, the same question with another method, which is the first shift theorem, because this question involve the combination of the exponent with another function t square here. So we also can use the first shift theorem. So to use the first shift theorem, let me rearrange so that you will see it clearly. We have a function of exponent 5t times with t to the power of 2. By first shift theorem, you will get your Laplace transformation as fs minus a, where fs is the Laplace transformation of the function t square here. Okay, so let's first we find what is our fs. So fs is the Laplace transformation of the function t square. Okay, so by using the formula of Laplace transformation for the function t square, which is the formula is n factorial over s n plus 1, our n now is equal to 3. Therefore, what you will have as your fs is equal to 2 factorial over s to the power of 3. Therefore, what you will have here is 2 over s to the power of 3. Okay, and by using first shift theorem, you need to find the Laplace transformation for the combination of two functions, where one of them is the exponential, by using the formula f s minus a. Now from this equation you can see that your a is equal to 5, so every s you will plus with negative 5. So what you will have as your solution is 2 over s minus 5 to the power of 3. So you have the same solution as the derivative of the transform method. So for this kind of question, you can choose whether to use the derivative of the transform method or the first shift theorem, because they have the function of t and also exponent.